So we are recording, and Isaac, I will turn it over to you.
Thank you very much, Ashley. Would you be able to confirm that you can see my slides? Perfect. Thank you. Hello, everyone. Thank you very much. I'm very excited for the opportunity to speak with you all today about research data management. As Ashley said, I'm the research data librarian here at UK Libraries. So I'll get into a little bit more about what those services that I offer look like and my engagement with researchers in this presentation. But I'll also just note that I remain somewhat new to the UK community. I just graduated with my MSLIS in this past May of 2023. So for those of you who might be MSLIS students, I'm very close to the position that you all were in. So if that's something that you all ever want to talk about, what LIS education looks like now, or early career librarianship, very much always willing to talk with you about that. So the topic of this presentation today is going to be best practices for managing your research data. I'll also note that these slides sometimes tend to be a little bit content heavy in terms of what I present. I'm hoping to leave you with some discrete practices that you all can implement in your own research practices. And so in support of that, I've put all of the materials that I referenced today on a public OSF project space. I dropped the link into the Zoom chat, or you can also access that link that's shown on the screen. So anything that I referenced today, don't worry if you missed the link on a slide. These slides, as well as everything that I link out to, is available there. So a little bit about the services that I offer as research data librarian. If you are a faculty researcher, then I can help you with creating and implementing a data management plan, either as a document that you want to develop to drive your own research process, or a data management plan that you might be developing as part of an application for federal funding through the NSF, NEH, IMLS requirements for digital output plans, that type of thing I can help with. I can also help if you're looking for platforms for data management, such as OSF. That's one that I use for hosting my own materials here, but others as well. If you just sort of want to get a sense of what's out there and what might be appropriate for your research, I can make some recommendations. For those of you who are producing research data, I can help you with navigating the repository landscape to find the right place to host your data long term, so that you don't need to worry about the day-to-day preservation or access to it, as well as make sure that it is easily findable and citable by other people so that you can get credit for it as a first-class research output. And then finally, I am a resource to help you identify data sets for reuse. So particularly for those of you who might be graduate students in methods courses, where it's more about learning about the processes than it is about data collection elements, then come to me and I can help you find data sets that match the research question that you're interested in. But I'll also note that data reuse generally is very much hoped for benefit of the open science movement, and one where we're hoping to be able to see some more gains and decreased redundancy in research processes by reusing and reinterpreting and reanalyzing what other researchers have already produced. So I always like to start out by providing a definition of research data management. Data management is one of those terms that can mean a lot of different things to a lot of different people, and also will vary from context to context as well. So for the sake of what I'm talking about here, I really like this definition from Kristen Briney, another data services librarian. Data management is the compilation of many small practices that make your data easier to understand, easier to find, easier to understand, less likely to be lost, and more likely to be usable during a project or 10 years later. And the thing that I really like about this definition is that it emphasizes that research data management is not just one thing. Sometimes that's how we might treat it or talk about it, but I much prefer to think about data management as a collection of a lot of different practices. And there's good news and bad news to that. The bad news is that it means that data management is not, one lever you can pull, one form you can fill out, or one process you can complete at the start of your research process, and then clap your hands and say that your data is well managed forever and ever. No, unfortunately, it's something that needs to be maintained and done actively throughout the research process. The good news there is that means that research data management can be iterative or it can be modular. You can get a sense of the different practices that are out there, what makes the most sense for the research that you're doing, and then add on different procedures and experiment with what works for you, what improves your own efficiency. And so that means that, you don't need to worry about there being one thing out there that you need to do to make your research data well managed. Instead, you can think of it in terms of lots of different things that you can try out and get working with to help your process. Another way that it's useful to think about research data management is through the UK Data Retention and Ownership Policy. This is a policy that covers all research that takes place at UK and all data that's generated, shared, and preserved through that process. And this policy outlines a number of different responsibilities that principal investigators have for any data that they're generating. And those data management responsibilities include access, disaster preparedness, so making sure that it remains available in following some sort of disaster, making sure that data has documentation and organization. So in other words, making sure that it's well described and that others are able to access it. And then lastly, preservation, making sure that it's available in the long term and not just for the life of a single research project. I encourage you to take a look at that entire policy. It is actually surprisingly readable in terms of what it lays out. And so it's useful to just get a sense of what expectations are set by the university in terms of data management for you. So with those definitions in mind, why is data management something that we should care about? There are a few different reasons. The first of those is mandates. So policies such as the UK Data Retention and Ownership Policy, as well as requirements for federal funders for data management or data sharing, require that data management is something that you're planning for before you start your research, and that it's something that you're actually implementing and carrying through over the life of a grant or a research project. Another thing to keep in mind is that within your scholarly community, it's possible that the data that you produce might be audited if there are questions about how that data was gathered, the use that it's being put to, or the analysis and findings that you produced from it. So making sure that your data is clear both for yourself and potentially for outside users as well is very important to make sure that you're complying with those research mandates. Additionally, it's important to think about data management as improving your research impact. So if you make your data accessible and easily understandable, if you are deciding to share it, then data that's well documented and easy to use is more likely to be reused by others. That means that it's more likely that it will be recited. But it also just means that others will see that you are, a well-organized researcher and a potential good collaborator. So that introduces new research opportunities for you as well, based on your data management practices. And then finally, good data management improves your research efficiency. There's the saying that an ounce of prevention is worth a pound of cure, and that very much applies when it comes to data management. Because if you take some time, especially during the planning stages of a research project, to think about some data management policies or practices that you can implement, then you will be able to head off problems as they come up much more quickly and even avoid those problems entirely. And that means that you will actually have more time and energy to focus on the research on the research that is most interesting to you and that really drives you. If you take just a little bit of time to think about data management and you stick to those policies you set for yourself or for your research group, then you can avoid those issues and focus on discovery. So for the rest of this presentation, my goal is going to be to cover 5 different data management practices across a variety of different areas that are all things that you can potentially implement today on the next project that you're currently planning for, even on a project that you're currently working on right now. So these are going to be some fairly general principles that apply across a lot of different domains and disciplines, and information sciences is obviously one that is just sort of by its nature very interdisciplinary. And so I hope that you all find opportunities to put some of these into your own practices as well. And I'll also note that for those of you who are students, you can also think about applying these policies to the research that you're conducting as well, or even on a smaller scale in terms of thinking about, some policies for just organizing material or data that you're producing over the course of a single semester, for example. That can be a good way of taking some time to try out different practices and see what's sustainable for yourself. So the first one that I want to get started with is developing a file naming convention. So I'm sure all of us have been in situations like the two in these comics here, like the example on the left from XKCD, a wonderful webcomic, if you're not familiar with it. Showing what a lot of our documents or downloads folders might look like. Just a lot of documents that we saved in a hurry, never really thought much about again, assigned random names to. And then years or months later, we come back to them and need to get some piece of information out of them, but we have no idea which file is which, and we don't know how we're actually going to find the information that it is that we're looking for. Or maybe something like the situation on the right that applies more in the context of manuscript or draft editing, working on a draft for a dissertation or for an article chapter or other publication where we are constantly making revisions to that. We're working with collaborators, we're getting feedback, and we don't have any consistent way of naming naming those files or knowing which one is the correct version. The absolute, a very annoying situation here is you're working on an article or other publication with a collaborator, you're passing those drafts back and forth, and then you make a bunch of changes and revisions only to realize that your collaborator is working off a completely different version of that file, and then you need to figure out how you're going to reconcile those. And so these are the types of problems in research that file naming conventions can help with by providing some clear and consistent rules for the way that you name the files that you work with. So a file naming convention, like I said, is more or less a set of rules that you're able to apply consistently to files that you work with. They might primarily be focused on data that you're collecting, but you can apply them in other domains as well. And there are a few different good best practices and principles for when you're creating a file naming convention. The first of those is to make sure that the naming convention you use is descriptive. So highlight contextually important information in the name of a file that will help you to distinguish it from other files that you produce. So for example, maybe you have conducted a series of interviews and the data that you're working with are transcript files of those interviews. It will probably be important to include a participant ID in the name of each file so that you can tell those apart from one another just by looking at the file name, and you're less likely to get them mixed up across participants. Also, it's important to keep them brief. You might be working with software where the file names themselves actually do matter a great deal, but it's also important to keep in mind that a file naming convention is meant to help you as a human reader better organize your files and know what's contained within them. And so for that reason, the sort of rule of thumb is to keep file names to around 32 characters or less. That's just because if you think about the Finder window on your computer, once you get past 32 characters, the name of the file is going to run off the edge there, and then you won't actually be able to read it. So it doesn't matter if your name is super descriptive if you aren't actually able to see the names of those files in full. So one thing you might want to do is consider including abbreviations in your file names. So for example, rather than writing out the name Metropolitan Water District, if that's something important to your files, use an abbreviation like MWD, but make sure that you document that abbreviation somewhere. And lastly, as a general rule, avoid any special characters or spaces when you're working with a file naming convention. So characters like a question mark, hashtag, @ or slash signs, since those will often cause errors for different operating systems when they're trying to parse your files. A lot of operating systems will actually warn you against using some of those characters. So that's good, but don't try incorporating that into your file name. Spaces are often okay to use. And, if we think about files that we want to be human readable, it's often just easier for ourselves to have spaces there. But that does introduce opportunities for inconsistency across files that we are trying to name in a consistent way. So my personal preference is to, when using a file naming convention, connect the different pieces of those file names using underscores so that I can clearly see when one piece of that ends and when the next begins. So this is an example of what a file naming convention could look like in practice. I imagine here a study that's looking at air pollutants in different US cities. And just to walk through this, the start of this file naming convention begins with the date of data collection, which we can easily imagine being important in this context. And we write that date. We write that date in the year, month, day format. So this would read 2023, 10/18, or October 18th, 2023. There are a couple of different reasons for using that date format. The most obvious, or one of the most important rather, is that it's an unambiguous date format that if we think about, the way that different countries write out a date format, some begin with months, others begin with days. And that can lead to confusion about what a date refers to. So if we go in the order of year, month, day, then that's an unambiguous format, regardless of what collaborators you're working with or what date system they're used to using. So the other piece of information that might be contextually important here is the city where this reading was taken from if we're measuring different cities. So we will put in a name like Lexington. And then finally, it might be important for us to record the pollutant that's being measured. So in this case, we could be using lead, which is abbreviated using its atomic symbol, Pb. And we might use other atomic symbols for other atoms or molecules, other pollutants that we're studying here. And then putting this file naming convention together, we connect these three different pieces of file metadata using an underscore so that we can easily see where one piece ends and the next one begins. So one thing I want to emphasize when it comes to file naming is that the point of this is really to make it easier for yourself to be able to manipulate and keep track of the data that you have. And so that means that there's a lot of room for trying out what works best for you here. So for example, continuing on with the same file naming convention, there isn't necessarily a right way to put the different pieces of the name in order here. In the example on the left, these are file names that are listed with the date first. And you'll notice that because of the date format that we used, we can easily sort these files in chronological order based on their names. So everything from October 16th, 2023, those three files appear together, then the three files from the 17th, and then the three from the 18th. But maybe just given our research process, it makes more sense for us to lead with city first instead. That's a perfectly fine choice. And we can see here, now we have all of the readings for Chicago together on the 16th, 17th, and 18th, then all the readings for Lexington in the same date order, and then finally all the readings for Louisville. So it takes some time to think about when you're making your own convention here that as much as there are common practices of what's good information to include, you can really make this your own based on what's going to be important to you. So one of the resources that I link out to on the slides here, and like I said, it's available on the OSF project space, is a worksheet for developing your own file naming convention. So this is a process where you can print it out if you prefer just generating some ideas by hand or just type onto the Word document. It asks some questions about your own research and what data you want your convention to cover to help you think about what's going to make a useful convention for yourself. The first of those questions to ask is just what group of files do you want this naming convention to cover? This is not meant to suggest that you have one set of rules that you apply to every single file that you ever generate. It's much more common to think of a naming convention as applying to one individual research project or perhaps even one type of file or type of data that you're generating within that project. That being said, if it turns out to be a useful one that works for you, you can certainly copy that to other ones as well but it's important to just sort of clearly delineate what you want to cover with this convention. And then ask yourself what makes each, what bits of information or metadata make each of the files that you have distinct. That's generally a good rule for thinking about what information you want to put into the title. Once you have that list of elements, is there anything there that you think should be abbreviated in order to save some space? What order do you want the elements of the title to appear in, of the file name to appear in order to make it easier for yourself to search through those files? What characters will you use to separate each piece of metadata? And then lastly, do you need to track different versions of each file? If so, maybe you should also include a version number in your file names as well. When it comes to file naming conventions, I think that sometimes we can get very excited about, the idea of implementing one. We might come up with one and then discover that we can't remember exactly what goes in it each time when it comes to name files. And so that's why I recommend having a copy of your file naming convention at your workstation. Maybe that's something that you physically print out and stick next to your computer. Maybe it's just a document on your computer that you have easy access to, but just write out the rules for yourself that you want to use for that file naming convention. That will make it easier to implement, especially when you first get started with it, until it becomes easier for you to implement on a consistent basis. So speaking of writing things down, the next topic that I want to cover are some different strategies for data documentation. And so just to give an example of why this matters, let's say that that we're presented with tabular data in this form. We might be able to kind of guess at what's going on here, but without additional context, there is a lot of opportunity for confusion or ambiguity in this type of data. And just to sort of run through that, we know that this first column is measuring time, but we don't have any information about what units are being used here to measure it. Same thing with age. These look like kind of strange units to be applying for age. So maybe it's seconds, maybe it's hours, days, years. We really can't tell. And then with heart rate, maybe we would feel safer assuming that that's beats per minute or some other standard heart rate convention. Although even that, we might not be able to safely assume. But on top of that, this zero value here is very confusing. Does it indicate that a reading was taken and that reading was zero? Is it supposed to indicate that a measurement was just missed and that's how that's filled in? We really can't tell just by looking at the data by itself. And this is just one example of a situation in which data documentation matters. Essentially, without additional context that you as a researcher provide, other people and other researchers are going to have a really hard time working with your data. And those other researchers can include yourself in the future. Things that might have seemed obvious to you at the time and didn't need any explanation, you might come back to data a little while later and suddenly realize that you don't know what units you measured things in, what units you're using for how you're representing null values, and those sorts of things. So I'm going to go through a few different examples of data documentation that you might want to consider implementing. The first one of those is a README file. And a README file is designed to give a high-level description of a set of files, so particularly those associated with a given research project or other research output. And they give users information about the data contained within. So how it was created, how the files within it are organized, any methodological information, any information that people will need to interpret or reuse any data that they find within. Traditionally, README files are formatted as plain text documents. The reasoning for that is that you don't need to worry about any loss of information when you are converting from one file format to another. A text file is a very simple and plain format that that is open the same on most operating systems, and so you don't need to worry about it looking different for different users. That being said, a lot of these principles could also be applied just by putting this information into a Word document or other document if that's easier for you to work with or think about. So don't take this as a rule that it has to be a plain text file. You can also think about having both a top-level README file for a project that covers the project as a whole, as well as more specific ones for subsets of project or subsets of files if it's a very complex one where that additional context is necessary. So just some basic information it's good to include in a project level README file includes the project title and author contact information, sharing and access information so that others know where they can find the associated data and how they're allowed to reuse it, how you would like to be cited when people reuse it, that kind of thing. Folder and file descriptions. So if you develop, for example, a file naming convention, your README would be a good place to include that information so that others can interpret the file names that you've designed as well. Same with descriptions of what goes into each of your folders. And finally, methodological information about how the data was collected. One thing that I do a lot of work with is data repositories where researchers share data. And one thing that can be kind of frustrating is even though the data is accessible there, there's not always very good descriptions of where that data came from or how it's organized. And some researchers will link out to an associated publication with their data that uses that data and will just kind of say, oh, if someone wants to reuse this, they can go read my article and then know about the methodology I used. The problem with that, though, can be that when you are sharing your data, a README file will actually be included with all of the other data files itself, whereas the article describing the methodology might not be. And so including all of that information in a README is a better way to make sure that that information migrates with your data and it will help avoid misinterpretations by other users. I link out to a resource from Cornell Data Services on creating a README file that can be very useful here when it comes to getting started. It's just sort of a blank template with a lot of different areas that you can fill in. And you'll notice that some of the information in a README file is useful more in a data sharing context, while other information, such as a folder list, can be useful to you as a researcher while your research is actually ongoing. So documenting things for yourself or for your research team. Another documentation practice I want to highlight is data dictionaries. So this solves the data dictionaries can address the problem that we talked about earlier of tabular data that might be kind of ambiguous in its meaning. So the idea of a data dictionary is essentially just to provide descriptions of each variable in your data set with information like its definition, the units that it's entered in, and then entries for missing values. Maybe that's zeros, maybe that's NA, but preferably not blank. And then someone who's reusing your data who has access to that data dictionary will be able to tell what everything in that table indicates. This can also be very useful if you're a researcher who's working with student assistants or other people who are playing a role in data entry. Having a data dictionary is very important to make sure the team as a whole is on the same page about what everything means. And then I include a link as well to getting started with a data dictionary through a resource made available by Open Science Framework. Last documentation practice I'll mention is just code commenting. So if you work with programming scripts at all, like Python or R, it's very important to make sure that you include comments throughout your code to explain what different functions you might do, what arguments they might take, how others might use and apply them, just so that everyone can understand what those functions do and how best to make use of them. This can be kind of difficult, especially when we're in the early phases of working on a project and really experimenting with things. You know, the code doesn't even work right yet, so why are we going to spend time documenting it? So one thing that I recommend doing is just try to make it a habit, if you do work with code, to save 5 minutes at the end of each of your work sessions to just review any new code you've written or edited during that time and look for opportunities to add comments that describe what it is that you do. That can make it a more sustainable practice over time, and then you can clean it up before you actually share it out. So the third topic that I wanted to discuss are data backup practices, as well as testing of data that you produce, or of backup policies that you have. Before I go on, though, I just want to make sure that we distinguish between backing up data and data preservation. Preservation is another term that we use that can mean a lot of different things in different contexts, but overall, it really refers to thinking about all of those practices that make sure that data sets remain available in the long-term future. So data backups are one practice within that. Backing up your data is the process of copying files so that you're able to restore data in the event of loss of data from your primary workstation or workspace. And data backups are one element of preservation, but there are others as well. So if you're developing a data preservation policy, then make sure that you consider other topics like file conversions or file migrations and bit level preservation practices as well, all of which are topics that we can help you out with at the library. So that being said, though, data backups on their own are still very important. A lot of times we sometimes tend to outsource thinking about backups to cloud service providers. So maybe you put a lot of your files in OneDrive or Dropbox or Google Drive or something like that. And all of those companies do, in fact, have their own backup policies and practices. So that can be very helpful. But it's important to keep in mind that they are not necessarily foolproof. There was a situation in 2014 where one service provider, Deduce, lost lost access to its own systems. And then when it went to try and back up or restore user data from a backup that it had, it discovered that the data wasn't actually backing up correctly, and they weren't able to restore it in the way that they thought. So this is not to knock on any individual provider here. It's just sort of to keep in mind that we shouldn't be outsourcing the entirety of our thinking about data backups to outside providers. The golden rule of thinking about data backups is known as the 3-2-1 rule. And that refers to having at least 3 copies of your data on 2 different types of storage media with at least 1 copy of your data stored offsite. So I realize that this can be a lot to ask depending on the type of the scale of the project that you're working on. And so just keep in mind any number of backups that you have are better than none at all. But if you are producing data that is highly valuable, either for yourself and for your own research enterprise, or just because it's very expensive to produce, or you're not going to be able to reproduce it if you lose it, then definitely do think about ways that you can follow the 3-2-1 rule to ensure that you're well protected against physical disasters, against failures of certain types of storage media, about loss of access to a particular location where you access your data. So an important part of the 3-2-1 rule is making sure you have a diverse set of media options for storing your data and storing your backups. So your personal computer or laptop or your work computer is usually a good option for storing at least 1 copy of your data. That makes sense, because then it's always available for you to be able to access locally if it's of reasonable size for that. So an easy way to get started with a data backup process is just to buy an external hard drive that you can connect to your computer on a regular basis and make sure that you're regularly backing up your files and particularly the important ones to that external hard drive. That way, if something happens to your computer, if it gets lost or stolen, or physically, if you drop it, if it's destroyed in some way, then you can use that external hard drive to back it up. If you want to think about more robust and complex options, you can also look into using local servers that the Center for Computational Sciences can help with, or your departmental IT can help as well. And CCS can also help you with setting up magnetic tape storage as well. That's a good option if you're producing very large amounts of data that you need to have a backup of, but don't necessarily need to utilize on a regular basis. Tape drives are pretty space efficient there. So some things to avoid when backing up your data: don't use USB flash drives. Those are good for short-term file transfers, but flash storage is less stable than other forms of storage, like on hard drives. And so as a result, it's more likely to get corrupted or lost over time. So don't think that just because you've saved files to a flash drive, that that's going to serve as a safe backup for you long term. And then also just avoid obsolete media. So if you've backed up a lot of data in the past onto CDs, but you don't have a CD drive and aren't sure where you would get one, then that's not a very accessible backup for you if you ever need to restore data off it. So you'll notice I didn't mention cloud storage on there as an option, and that's because cloud storage is sort of in its own special space here. definitely do think about using an option like OneDrive at UK as a way of syncing your files to make sure that they remain accessible. That can be a very easy and convenient option since you don't need to think about it much. But just do keep in mind that you never know when the terms of service of a company are going to change. This happened with Google Drive, where until a few years ago, Google Drive allowed unlimited storage for academic researchers and then cut that off, which meant that a lot of researchers relatively quickly needed to figure out where they were going to move all of their data off of Google servers. Also keep in mind that pricing might change as well, as in that Google example. So it might not actually, that backup option might not actually be as stable for you as you think. And then lastly, just keep in mind that if you do have files synced directly between your personal computer and your OneDrive, for example, then if you remove a file in one location, then you risk removing it in both locations. And then some final tips for thinking about a backup policy. First of all, definitely make sure that you test them out and that you can actually recover data from that external hard drive or from that other source in the way that you expect to be able to. There's nothing worse than, setting up a backup policy and then needing to recover data and suddenly finding that you set it up incorrectly and that hard drive doesn't actually have anything that it was supposed to copy. Additionally, as much as possible, make data backups a habitual part of your workflow. That makes them a lot easier to implement on a regular basis and means you'll have much more recent copies of your data to draw from. And then finally, do just remember that any number of backups is better than none at all. So even if you don't feel that you need to implement the full 3-2-1 policy, or just don't have the resources for it, do think about, are there ways that you can make just even one extra copy of super essential data that you work with? So fourth, I want to consider some special considerations for research groups when it comes to data management. Um, so data management is something that everyone on a research team is contributing to, whether or not they know it or are sort of doing that explicitly or just implicitly. And having explicit data management policies and responsibilities laid out can avoid a number of difficult situations that can arise. A very common one here is researchers at an institution let graduate students or postdocs set up a OneDrive space or a Google Drive space for the lab or for the team. And then when that researcher leaves the institution, the PI suddenly loses access to all of those files because because the account was deleted. Maybe you do have a backup policy, but the person who is responsible for that leaves the team and you never actually reassign that to anyone. So then no backups are taking place. Or maybe you don't have a data dictionary or other form of documentation, and you've got a bunch of different research assistants who are all entering data using their own criteria without communicating with one another. And then suddenly your data sets are all your variables are all in different formats. So I link out here to a checklist that teams can use for setting some data management policies. And that just goes through sort of a series of questions of things that you might want to consider if you are collaborating with others in data management responsibilities to make sure everything is explicitly defined. So some of those key responsibilities include being the system level owner of shared files. So that should hopefully be the principal investigator or someone who has a similarly stable role on a project. But you can assign out other responsibilities such as creating and updating data documentation, conducting data or assurance or data quality checks to catch any problems early on before they expand over time, and then performing and checking backups if that's something that your team is doing. Relatedly here, it's important to think about data on or team onboarding and offboarding for data management, since team turnover can be a big thing that causes data management practices to not be put into place. So when new members join your team, make sure that they're receiving all relevant data documentation guides, any descriptions of policies that your team carries out. If you are assigning them any data management responsibilities, make sure they understand those and have an opportunity to ask questions about them, and make sure they have access to all the files that they'll need to complete any work on the project. And then consider offboarding as well for people who are leaving your team. Review data management responsibilities that a person conducted so that they can be reassigned to remaining team members if necessary. Um, Ideally, they won't be the administrative owner of any important files on the team, but it is always good to do a final check for those, just so that ownership can be transferred if necessary. And then finally, particularly if you're working with sensitive data, be sure to remove their access from systems containing data that they no longer need access to. Like I said, that's most important in the case of private information, but it's also just good practice as well. And then the final and sort of summative tip that I have here is to self-audit data from a project that you've previously done. So a lot of what I've covered here can be applied across a lot of different disciplines or different types of research methods. But the way that it will look specifically for you depends a lot on your own research practices, the methods that you use, the research culture or scholarly community that you're a part of. And so that means that the best way to figure out what the most high impact data management practice is for you to implement will be to look at data that you have actually collected yourself from a past project to see how it can be improved. And so I encourage you to, after this presentation, find data from a past project. Honestly, the more distant from now, the better, to get a sense of how well you would be able to reuse or reanalyze that data. And so when you're exploring those data files, some general questions to ask yourself include, can you easily tell what's what? Do the file names make sense in a way where does it look like this is a complete set of data? Are there any missing files? What's going on with the names? That kind of thing. If this is data that's part of a publication or other project that you've done, can you reproduce the analysis that you've done there? Or another way to think about it is, what are the number of steps you need to take to reproduce that analysis? Do you just need to rerun some code scripts that you've done? Do you need to reclean the data? Just think about, how easily you can reproduce those results. Are there any risks to the data getting accidentally deleted or corrupted? Are you using software that is out of date or no longer supported, or has been updated in such a way that it might impact your data? And then lastly, is this data that you would stand by and be prepared to share with a mentor, colleague, or external auditor? Those are all situations that do come up if there are questions that arise about your data, even if you're not necessarily sharing it. And so making sure that data at the conclusion of a project is something that you're ready to stand by in those types of situations is very important and is a good indicator of whether or not your data is well managed. Some more specific questions to ask when you're looking at your data is, do the folder and file names make sense? Actually go into all of those files and open them up and confirm that their names match their contents. And then relatedly, you want to do that just to confirm that you actually can open all of the files. Sometimes software might have been updated or which can lead to a loss of information. So for just as one example, maybe you're working off an old version of Excel and there have been changes to the functions that you've used there or some macros that you've developed, and you open it up and realize that those things are broken. That would be an indication that you can consider some ways of moving your data to more stable formats to prevent that sort of loss for future projects. Digging into those files a little more, are the variable names that you use interpretable, and do you have documentation for their meaning somewhere in a data dictionary, in a README file, in any other form of documentation? And then are the entries for all of those variables consistently formatted in a clear way that makes sense and prevents errors from cropping up? And then last overall question is just, is there anything that you assumed at the time when you were working on this data was just so obvious that it wouldn't need clarification that now no longer makes sense to you? That's a good indication of some areas where you may need to improve some documentation practices in order to make sure that everything is in fact clear in the long term and that your data maintains its value even after you're no longer actively using it. So those are the data management tips that I have for you all today. And I just want to leave you with the thought that data management is a journey and not a destination. Like I said at the beginning, even if you implemented all of these practices, that wouldn't mean that your data is magically well managed and it's not something that you need to think about anymore. But that also means that it's data management is a realm where even iterative improvements can have a big impact. So please don't think of this as something, insurmountable either. Think of it as a series of small practices that you can start implementing today to make your research practices just a little bit better. And then the last thing before I turn to questions is as research data librarian, I maintain a number of different resources for data management. The home for that is the Research Data Services at UK LibGuide. This covers a lot of the information I've covered in this presentation in a little bit more depth, as well as how these data management policies apply across different funder or administrative landscapes as well. So if you want to be able to talk more about a specific project that you have or what your data management practices look like, please feel free to check out those resources or contact me to set up a consultation. And so with that, thank you all very much for your time this evening, and I'm open to any questions you have.
Thank you so much, Isaac. We'll leave the slide up for just a second in case anybody wants to jot down any notes. But at this point, the floor is open for questions. Feel free to turn your mics on and ask them or type them in the chat. The floor is yours, everybody.
So I guess that means you covered everything. Um, I will ask something. So you mentioned that flash drives are not safe storage. Um, do you have any thoughts about solid state drives now that we're moving away from spinning disks and tape backups and similar things like that?
Mm. Um, Solid state drives, I sort of put under the context of hard drives writ large. I'm not sure how, I don't have a good sense sort of how, in terms of like long-term preservation over whether or not they're more reliable than spinning state drives. I think they might, spinning drives might actually be a bit more persistent in terms of long-term preservation, but don't quote me on that. The but that would be to say just, it is important to think about making sure you have multiple copies of your data whenever possible, just to make sure that if one storage media fails, then the other one you would have a backup option there for.
So I've got one more if
Mhm.
nobody else does. So how often do people act surprised when they find out that certain media is not good for long-term storage? Like especially um, CDR, DVD-R, etc., I know is notoriously one of the worst, yet people don't seem to think about it.
I think it has less to do. I think it's less sort of people being surprised that it's not good, that it's not good for long-term preservation, and more just sort of, they used whatever media made sense at the time for them and then never really revisit that question to think about it. I'm sure this is an experience that many of us have had just in our personal lives with, VHS tapes or whatever else that contain precious childhood memories that we no longer have access to. There's a very famous story of, I'm not sure. I think I forget what kind of tape it was on, but of NASA actually losing the footage of the original moon landing because they had limited storage, and without realizing it, future NASA employees copied over the only existing tapes of the moon landing. And so we don't have that like perspective from the moon itself, which is kind of sad. But yeah, when you think about situations like those, I think it's less people choosing something that it, it, I don't think people at the time are thinking, this is going to be able to live on this format forever. It's more just that's not a question that they have in mind when they're working with it. And I think there's a lot more thought now about sustainability of research and of digital projects. And now there's a very robust data repository landscape out there. And that can be a good way of sort of thinking about preserving your data for the long term by partnering with a repository as a way of doing that. But yeah, I think it has a lot more to do with the fact that, we kind of just implicitly assume we need data for as long as we have it. And then by the time that we might start thinking about long-term storage or long-term preservation, we're no longer working with that data on a regular basis. And so it just doesn't feel as important or as urgent to need to be able to get access to. Yeah, and there's a comment in the chat about how this applies with movie archives and digital archives that can degrade as well. And, I think this is part of how I think of a role like mine as a research data librarian is in being of like the longer tradition of librarianship, even though it's a very different kind of role. It's, libraries are institutions that are fundamentally concerned with long-term access to knowledge. And part of that means, information organization, but part of it also means just thinking about materiality of data, of information, to make sure that things are migrated to new files or new media when necessary to make sure that they remain available.
Isaac, I have some follow-up question just based upon your comment. So can you give us some kind of your main work daily basis regarding your research data librarianship, because I think that many of the students are kind of pursuing academic librarianship and interested in following this research data librarianship. So I am wondering whether kind of you can give us some hint of how your day look like, and then what kind of the outreach you perform for faculty member and graduate student, because sometimes we don't know and how many target audience know about this kind of research data management, and before they have a research grant and they have to deposit research data. So that's my question.
Yeah. So I work across all different disciplines here at UK. And so, if you know of any faculty members in other colleges, please know that if they have questions about data management, you can send them my way. But the services that I provide sort of look different depending on the particular research needs there. So, for example, the National Institutes of Health last year started implementing a new data management and sharing policy that has been in effect for about 1 year now. And so that means that a lot of people in the medical or health sciences who are applying for NIH grants need support when it comes to that particular data management and sharing plan. So that kind of work that I do is very sort of policy oriented. The value that I serve as a librarian is having an understanding of what the NIH is looking for on those documents, and then being able to work with researchers to describe their data and then find an appropriate repository for long-term sharing of it there. So that, and I provide data management plan support in other areas as well. So for NEH or IMLS grants as well, or like the NSF or Department of Energy, for example. But just sort of given the current policy moment, that's looked like a lot of support for researchers applying for NIH funds. So that's some specific work that I do. I also do a lot of just sort of general data management instruction like this. Data management I've found to be a very fascinating topic because across disciplines, it's something that a lot of researchers will tell you is important, but won't necessarily tell you at which point in their graduate education they receive data management training or where they have time to provide it to their own students. And so as a result of that, that means that there can honestly be a lot of feelings of just shame when it comes to data management practices, that people assume that this is something that everyone around them seems to be doing very well, and they think that they're, not necessarily up to it, but aren't sure where they're supposed to be able to get more support for it. So that's why I do a lot of instruction, like in this format, that is very focused on just sort of broad principles in terms of what you should think about generally, and then some discrete practices that you might want to implement for yourself. And then similar to that, I'll do consultations with research groups as a whole, where I sort of play the role of mediator, almost, of just sort of asking questions like, okay, so when two of you are working together, or if you need to access someone else's data in your research group, how does that generally go? Can you tell what's going on there, or do you need to like sit down and have a long conversation with them first, and then sort of use that as a way of helping research groups implement practices that will actually be sustainable. And then lastly, the last sort of like big area that I work in is providing some more in-depth support to some projects when it comes to data analysis. That's one that can be sort of more particular to like a match of the particular skills that I have and what a research group needs, but there are opportunities for that as well, which is quite exciting. And then last thing I'll mention for students as well is one thing I have recently started doing is much more general like data analysis conversations. I do have training in some specific tools, but I've also found that when working with graduate students in particular, sometimes it's useful to just sort of sit down and say, okay, you've collected this data, what results or like what analysis are you trying to perform, and how does the data need to be transformed in order to reach those points? Is the data that you've collected actually, does it align with the research question that you have? Do you need to make changes there? And so a lot of those have to do more with general data literacy than they do necessarily with specific methods as well. And those are great conversations to get to have.
We've got about 4 minutes left, and you mentioned recently earning your Master of Library Science. I wonder if you have any advice for our students, some of whom will be graduating soon, some of whom have just started the program, any sort of early career advice that you would pass on to them?
Um, I would say, like, particularly, when you're first starting out, I definitely felt that, it's only 2 years. It's such a short program. I needed to like start thinking about the job market right away. And so for those of you who, might be earlier on in the program, I would say do just take some time to relax, breathe, and just follow some things that you feel interested in. Data librarianship was not something that, I was really even aware of as a type of librarian at the time that I started my program. And it was something that I was able to discover over time through different classes that I took. And then, develop some expertise and to be able to do this job. So, it is a professional degree, and you definitely do want to be thinking about, the role that your classes will play in helping you when it comes time to the job market. But do take some time to just sort of, embrace some curiosity as well when it comes to, pursuing your interests, and be open to discovering new things that you might not have been aware of when you first started the degree program. Um, and then for those of you, who might be graduating in May or closer to the end of the program, I know that can be an extremely stressful time, and I would say just practice self-care. Know that there is a lot of luck when it comes to job applications, and the jobs that you get accepted to or get rejected to are not a reflection on you as a person. And one specific practice there is, if you know other people in the program, try to develop a bit of a support group or support network around that. And do so by creating an environment where you can both commiserate when necessary, but also celebrate each other's successes. That was something that I did with some friends in my last year of graduate school. We would meet on a biweekly basis, and we would have 15 minutes at the start of just complaints, whatever was frustrating, that like job we spent so much time working on and then got rejected from automatically by a system, or, that any other frustrations you might face. And then we sort of capped that at the first 15 minutes, and then turn to constructive things of, okay, what am I doing next? What next application am I going to go for? What am I excited about? What steps do I need to do to prepare myself? So yeah, that's the best advice that I have, but really good luck. And, it definitely can be a very difficult process, but don't give up with it.
Excellent advice. If there are any other questions, please feel free to share them now. If not, thank you all so much for joining us tonight for this webinar. And we have the very last one for spring 2024 coming up on April 15th, which is our Introduction to Open Education Resources webinar. So if you'd like to join us for that as well, we would love to have you. And I hope you all have a great evening.
Thank you, everyone.